Let's take a look at the last example for this section, see what we have. The often on-time parcel service, abbreviated OOPS, delivers a package to the wrong address with a probability of 5% on any delivery. Suppose that each delivery is, very important, independent of all the others. Now there are 7 packages scheduled to be delivered next Saturday. What's the probability that, here we go again, at least one of them will be delivered to the wrong address? Okay, so how about we go ahead and we come up with some notation here again to try to figure out how we might be able to notate things easily. All right, how about we go ahead and say that we'll have W stand for the package gets delivered to the wrong address. Okay, that seems like a pretty easy thing to remember. W is for wrong address. And then we could do something like C to stand for that it's delivered to the correct address. Okay, now we're told here in the question that the chances that it's delivered to the wrong address is going to be 5%, 0.05. So what's the probability that it's delivered to the correct address? Well, that would be 0.95. Okay, so let's think about what it is then that we're interested in here. Well, to help with that, again, I'm going to think quickly here about a sample space. And I'm going to think ultimately about how many packages, so I'll say the number of packages that could be delivered incorrectly. So I'm going to think about the sample space here. Now, I've worded it this way very particularly. You'll note that in the last video, when we wrote out our sample space, we actually wrote out all the different possibilities, and then on the side we kind of summarized how many tasks that was. Here we could do the same thing. We could try to specify which packages are going to end up being the ones that get delivered incorrectly, but that's actually going to be a lot of work and really tedious. Instead, I'm going to think here just about how many packages, what would be the number of packages that could end up going to the wrong address. Remember, 7 packages are scheduled to be delivered. So it's totally possible that no package goes to the wrong address. Maybe the company gets them all right. 1 could go to the wrong address, maybe 2, or 3, or 4, or 5, or 6, or 7. Notice though that writing out the number of, or the ways that this would work would be really difficult. For 0, it's not bad, but you can just start to think, like for 0, I would have to write down the case of like, let's see, no package gets delivered incorrectly, so that would be like C, 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 C. I'd have a bunch of C's in a row. But when I start thinking about how many different ways would there be to have one package delivered to the wrong spot, you can start to see how this can get really tedious really quickly. Because it could be that the first package is wrong, or it could be that the second package is wrong, or it could be that the third package is wrong, or it could be that the fourth package is wrong. Like, I'm going to have so many possibilities just for this case of 1. And I haven't even gotten started on 2 packages going to the wrong address and all the different ways it could be jumbled around in here. So sometimes writing out all the possibilities directly takes way too much work, and it's easier to just think, I'm interested in counting up the number of packages. So what we want is the probability of at least one of them being delivered to the wrong address, at least one W. And I want you to think about your sample space. Think about what it is you're interested in, and see if you can come up with a way to actually calculate this. Why don't you go ahead, click pause on the video, and give yourself a couple minutes to try to think through this. When you hit unpause, you'll see me work through the solution. Okay, well here's what you should note. If we want at least one W, then that means that we're interested in all of these cases. I'm interested in having one package or more delivered to the wrong address. So the only thing I don't want is 0 W's. That would be bad. So I would want to say that I'm interested in doing 1 minus the probability of them all being C. They all get delivered to the correct address. Notice that's the probability of C and C and C and C and C. That's 5 C's, 6, 7. And since these events are independent, I know how I can calculate that probability. That's just going to be the probability of C times itself 7 times, or I'll raise it to the 7th power. So that would be 1 minus 0.95 to the 7th power. Now if I crunch all this out in a calculator and I do the 1 minus, I should end up with the value of 0.3017. Again, the ideas in this section can be a bit confusing at first, so you got to make sure you spend time practicing. You got to do it, a lot of time. So go take a look at those worksheet questions, go through them, and of course, if you have any questions, you can check the solutions online. You can also feel free to let me know, and I'd be happy to help with anything that I can.